Many developers are afraid of using Unreal Engine for 2D games since they believe it doesn't perform well and it's hard to hit your frame rate target. But what if I told you that I got this blueprint-only Unreal Engine 2D game running at around 440 frames per second on my laptop and 370 FPS on the Steam Deck without putting a lot of effort into optimization? In this video I'll show you how I achieved this, in what scenarios high FPS like this is beneficial, and we'll also check out how many frames per second some Unreal Engine 2D games on Steam can achieve. But just to make sure we're all on the same page, I'll give you a quick primer on how frames per second affect the games we create. The frame rate, or FPS, simply means how many images are being generated or shown on the screen per second. If we have low FPS, the game is gonna be less responsive due to more input delay, and it will also look choppy since we get less images per second shown on the screen. With high frame rates, the game will look a lot smoother due to us seeing more images per second, and our inputs will also be registered quicker, which leads to the game feeling more responsive as well. Generating a high frame rate of course will require more computing power off your PC or game console, and this is the reason why even nowadays many games on less powerful devices like the Nintendo Switch are still running at around 30 FPS. The gold standard are 60 FPS, and the majority of consumers actually don't have a screen that is even able to show a frame rate higher than this. There are certain genres that greatly benefit from high frame rates of 144, 240 or even higher if you have the monitor with a Hertz value to support that. However, especially for 2D games, the benefit is negligible and you would most likely want to lock the game at 60 FPS by default to prevent unnecessary battery usage and heat generation. In this video we'll mostly use the Steam Deck as the main benchmark, and why is that? Because it's basically a low to mid-end PC, and if the game runs well on Steam Deck, we can be sure that it also runs on most PCs, the PlayStations and the Xboxes as well. The Nintendo Switch is our lowest common denominator, but if the rumors are true, we don't have to worry about it much longer. Let's get into the actual settings and how I was able to achieve such a high frame rate with Unreal Engine. When using the default project settings, the result was already better than I expected, but all in all not that impressive. I was able to run the game at around 320 FPS on my powerful laptop and around 165 FPS on the Steam Deck. But since we only really need to hit a stable 60 FPS, this would have already been enough to make Unreal Engine a valid choice for most 2D games, since the end user won't notice a difference anyway. However, at this point I still had a lot of unnecessary features turned on that won't benefit 2D games anyway and only use up computing resources. I turned off Lumen and Global Illumination altogether, which is the new next-gen lighting system with Unreal Engine 5. I also changed the reflection method from Lumen to none. This alone led to a performance increase of around 30% on my laptop, making the game run at around 410 FPS instead of 320. On Steam Deck the difference is even greater and it led to a 75% performance increase. The game now ran at around 285 FPS instead of 165. Lumen is mostly geared toward next-gen consoles and high-end PCs, and I believe it doesn't even work properly on Steam Deck anyway, so there's no point in keeping this on. We can take things a step further though with one really simple setting. In the project settings we can activate forward shading. This will change from the deferred rendering model to forward rendering. Forward rendering can be more performant in many cases, but if you use a lot of transparency and reflections there can be issues. For our 2D game however, this is necessary and gave us another big performance boost. On my laptop I went from 410 FPS with deferred rendering to 440 FPS, which is a 7% increase. Again, on the Steam Deck this effect is a lot more obvious, and we went from 285 FPS with deferred rendering to about 380 FPS with forward rendering. This is a performance increase of about 33% and puts us way above our target of 60 FPS. Outside of the rendering and Lumen settings, there are also many other small project and post-processing settings you'll want to adjust. Some of these have minor influence on the performance, but more so than that, they will prevent visual artifacts and make sure the sprite colors aren't washed out. I wrote a cheat sheet with all of these settings, which you can use as a reference whenever you make 2D games in Unreal Engine. In one of my Udemy courses I also teach you how to make a 2D action platformer, and we actually go over these steps when setting up the project. You can check both of these resources from the links in the description. So at this point we've already proven that you can make Unreal Engine viable for 2D games by only putting a couple of minutes into finding the optimal project settings. But there is much more you could do to optimize your games and make them run even better. However, these are things you'll do at a later time during the development process. So I just want to bring up a couple of 2D Unreal Engine games created by other developers that are nicely optimized and serve as an example of what is possible. The Unreal 2D game I found that runs at the highest frame rate is Guntastic. This is a simple party game which runs at around 430 FPS during combat on the Steam Deck, but goes all the way up to 600 FPS sometimes when not much is happening on the screen. Ender Lilies is a critically acclaimed best-selling Metroidvania made with Unreal Engine 4. It can run at up to 330 FPS on the Steam Deck, and even on the Nintendo Switch it runs at 60 FPS for the most part. When it comes to 2D 3D hybrid games, Octopath Traveler 2 is a shining example. This game runs at around 100 FPS on the Steam Deck on high graphics settings, and goes all the way up to 120 FPS with low graphics settings. On my laptop, I usually run it at a capped 120 FPS, since even though for the 2D animations it doesn't make much sense to run at more than 60 FPS, since this is a 2D 3D hybrid, particle effects and camera movement will look smoother at high frame rates. This game is also available on the Nintendo Switch, however since it's quite graphically intense, it is locked at 30 FPS. And this is quite common for the Nintendo Switch, even for non-Unreal Engine games. I believe this should give you a good overview of how performant Unreal Engine can actually be for 2D and 2D 3D hybrid games. If you want to know about even more successful 2D games made with Unreal Engine, I recommend that you check out this video.